Today I am going to discuss the maximization problem for assignment problem. Assignment problem in operations research. Previously I discussed general type of assignment problem. The normal problem is a minimization problem, and this is a special case which is maximization problem. Say these are the salespersons. Salespersons 1, salesperson 2, salesperson 3, and salesperson 4. And these are the marketplace. 4 markets 1, 2, 3, 4. If this salesperson attached to this sales market, then the profit will be earned, say, rupees 5 lakhs. This is 5. The same salesperson, if attached with the second selling market, then the profit will be earned 11 lakhs. In this way, the matrix has been given. Just I am again mentioning, say 9. What is this? That means if the salesperson, I am writing here, this is the salesperson. If the salesperson 3 is attached with the 4th marketplace, the markets in Calcutta, Siliguri, Asansol, different places like that, Purulia, like that. And these are the salespersons, Ramshan, like that. But if the 3rd salesperson is attached with this market, then profit will be earned 9 lakhs. In this way, the matrix reflects the profit earned connecting to different salespersons to different markets. Now, what you have to do? You have to find out which salesperson is to be attached with which marketplace so that the total profit will be maximum. This is the problem. That's why it is a maximization problem for assignment. What you will do? How will proceed? Because the general technique, that is Hungarian method, is a method for minimization. But this is a maximization problem. What you have to do first? First, you have to convert this problem to minimization problem, and then you have to proceed and apply the Hungarian method, by which you will minimize the assignment. And finally, again, you will find out the value of maximum profit. That will be the process for solving this type of problem. So first, you have to convert this maximization problem to minimization problem. How you will do that? I am writing here. Achha. For saving the space, I am doing the process on the same matrix. How you convert? You select the maximum profit element from this matrix. Which is the maximum profit? 5, 11, 7, 9. From all this, 12 is the maximum profit. You subtract all the elements of the matrix from this highest element first, and in that way you can convert the maximization problem to minimization problem. Just to save the space, I am doing on the same matrix. How will you do it? So you have to subtract all the elements from the highest element of the matrix. In this case, the highest element is 12. That's why subtract 5 from 12. Then it will be 7. Subtract 11 from 12. That is 1. Subtract all the elements from the highest element. This will be 4. And this will be 3 in this way. You will do it in a separate matrix. But in this case, just to save the space, as there is a limited space, I am doing on the same matrix. So 12 minus 5 means 7. Then this will be 5. This will be 3. And this will be 5. This will be 5. This is 12 minus 8. That is 4. This is 3. Now this will be 3. 12 minus 9, this will be 6, and this will be 4, this will be 1, and finally this will be 12 minus 12 is 0. Actually, this is the opportunity loss, you can say. By subtracting all the elements from the highest element, you have drawn an opportunity loss matrix. And if you minimize the loss, opportunity automatically will maximize the profit. That is the concept. Now we'll apply the Hungarian method for solving assignment problem on this matrix, step by step, and to solve this problem. Now step 1. What is the step 1? Step 1. Again I can solve the same matrix, but it is better. It is better that you have to do in a separate matrix. To save the space, I am doing on the same matrix. For each row, you find the minimum value element, lowest element, and subtract that element from all other elements. Okay. So, okay, it is better I am doing in a separate matrix. How we do it? Step 1. Okay. 1, 2, 3, and 4. 1, 2, 3, and 4. Find out the lowest element for the first row and subtract it from all other elements. In this case, the lowest element is 1. That's why 1 is to be subtracted from all other elements. 7 minus 1, this is the Hungarian method, is step 1. 6. 1 minus 1 is 0. Then 4 minus 1, then 4 minus 1 is 3. 3 minus 1 is 2. The same process is to be repeated for row 2. What is the lowest element? The lowest element for row 2 is 3. Subtract 3 from all other elements. 7 minus 3 is 4. Then 5 minus 3 is 2. 3 minus 3 is 0. And 5 minus 3 is 2. For third row, the minimum element is 3. Subtract this from all other elements. 5 minus 3 is 2. Then 5 minus 3 is 2. 4 minus 3 is 1. And 3 minus 3 is 0. And 3 minus 3 is 0. For fourth row, the lowest element is 0. If you subtract 0 from all other elements, it will remain 6, 4, 1, and 0. The first step is over. The same process is to be repeated column wise. That means for first column, you find out the lowest element and subtract from all other elements. Okay. Now, suppose I am erasing this, I will use this matrix for doing the step 2, and I will write here. That's why I am erasing this. Okay. Now, the lowest element for the first column is 2. Subtract from all other elements. 6 minus 2 is 4. 4 minus 2 is 2. This is step 2. Step 2. After converting to the minimization matrix. From minimization problem. 2 minus 2 is 0. 6 minus 2 is 4. The lowest element for this column is 0. That's why it will not change. 0, 2, 1, and 4. Again, the lowest element is 0 for this column. That's why it will remain same. 3, 0, 0, and 1. The final column, the fourth column, again, the lowest element is 0. That's why it will not change. 2, 2, 0, and 0. So row operations and column operations have been completed. Now the next process, you have to draw horizontal or vertical lines over the zeros in such a way the minimum number of lines will touch all the zeros. So this is step 1, this is step 2. On this matrix, now I have to draw minimum number of horizontal or vertical lines so that all the zeros will be touched, not diagonal or any other way. The horizontal line, suppose I am drawing, it is better to use different color. Suppose the horizontal lines. This is the horizontal lines. One. This is again another horizontal lines, and this is one horizontal lines, and this is also another horizontal to touch all the zeros. How many lines are required? You cannot draw the lines in this way or in this way. You can write only horizontal or vertical lines, but you should take care that minimum number of lines, not any number of lines. So I think this is the minimum number of lines. It is not possible to touch all the zeros by lesser number of lines. You can check it by yourself. How many lines are required? 1, 2, 3, 4. That means four number of lines are required to pass over all the zeros. And our criteria for optimum is if these horizontal and vertical lines, total number of horizontal and vertical lines is equal to the order of the matrix, then you have reached to the optimum. In this case, the total number of horizontal and vertical lines is 4. 1, 2, 3 and 1. This is 4. And the order of matrix is also 4. As the order of matrix and the number of lines crossed over the zeros is same. That means we have reached to the optimum. You need not to do further row or column operations or other operations. Now you have to do now the allocation step. Now this is step 3, which is called the allocation. Optimum has been reached. On this matrix you have to do the allocation. How will allocate, that I am going to discuss. I am taking the help of this matrix. I will show the allocation on this matrix. So first I put the elements of the matrix 4, 0 from this 3 and 2. 2, 2, 0, 2, 2, 2, 0, 2, 0, 1, 0, 0, 0, 1, 0 and 0, 4, 4, 1, 0, 4, 4, 1, 0, 1, 2, 3, 4. These are the salespersons and these are the marketplace 3 and 4. How you will allocate? You check if there is only one 0 to any row or column, you select that first, because you have to give allocation there positively. In this case, in this row only 1 0 is there. You must have to put allocation, because if you don't give allocation, then it will be left out. That's why you block it. I think this is the easy way to find out the allocations. Is there any row or column where only 1 0 is available? In this case, at the moment you block it, you allocate it, it is not possible to allocate here, because this salesperson is allocated with this job. That's why you cannot allocate this job to any other person. That's why you have to cross it. You check, is there any other 0 in any row? There is also a 0 in a single row. You have to put allocation. That's why I have blocked it. But here is no 0 horizontally or vertically. That's why I am not doing any cross. Third row is also 1 0. That's why you have to block it. But you cannot put any allocation here, as already you have given the allocation here. That means with salesperson 2, 3 job is allocated. You cannot allocate any other person with this job. That's why I have crossed it. And only 1 0 0 is left. You have to put allocation, that also. In this way you can give allocation. There are so many ways to decide how to allocate, but I am showing the easiest way in this case. This is the allocation for this case. That means what will be your answer for allocation? Your allocation will be for which the profit will be maximum. You should allocate salesperson. This is salesperson and this is the sales market. Selling market, you can say. How? First salesperson you attach to the market 2. This will be allocation. The second salesperson you should allocate with selling market 3, and third salesperson you have to attach with the market 1, and the fourth salesperson you have to attach with selling market 4. In this way you have to allocate. And what will be the maximum profit? To get the maximum profit, you have to put the profit value from the original table. Original table, once first sell person to sales market 2. What is the profit amount? Is 11. You check the original table given in your problem, then you will see the first person is allocated to sales market 2, then the profit will be 11. Next, second sales person to the market 3. Market 3 means profit will be 9. Third sales person when allocated to market 1, the profit is 7. And fourth salesperson is allocated with the market 12. Fourth salesperson is allocated with the market 4, and the profit is 12. Then what is the total profit? 9, 20, 30, 32, 39. So if it is in lakhs, then the total profit will be rupees 39. It may be in lakhs, crores, whatever it may be. This is the best allocation. You can check whether there is any multiple allocation or not. Is there any scope for multiple decision? That means is any other combination, the same maximum profit will come. You can check it, but you can see there is no option. If you put here, there is no. Therefore, I think this is the only decision. The best decision for maximization of profit will be this. That is the answer. Again, I am repeating. When you start the problem, first check it is a balanced problem or not. In this case, a balanced problem is given because it is a 4x4 problem. 4 salespersons are to be allocated with 4 marketplace. Which salesperson is to be allocated to which marketplace? That is the problem given. That means it is a balanced assignment problem. And next, you check whether it is a maximization problem or minimization problem, as it is a case of profit. That's why you can say it is a maximization problem. And if it is a maximization problem, then first you have to convert it to minimization problem by doing, I have already discussed, check the highest element and subtract all the elements from the highest element and convert it to the loss matrix. And if you minimize the loss, then automatically you will get the result for maximum profit. And then you will apply the Hungarian method for minimization of the assignment problem. That means loss matrix, and that I have already discussed. And finally, this will be the allocation, and that is the result by which the profit will be maximum. But be careful, after completing the allocations, you put the profit value, not the loss values, because it is asked what will be the maximum profit. That means this is the best allocation, but corresponding to profit you will get from the original table, and from that you can calculate the maximum profit. This is all about to solve the maximization problem. Next, I will discuss how to solve an unbalanced transportation problem. Okay, if you have any question, you please give to the comment box, and definitely I will give the answer. Thank you very much.